So if you don't have your review, I do have some extras.
Number 9. Yes.
This is subject, okay. Anyone need an extra copy of the review first? That was in the last paper that I gave you guys with your stuff from last class. So the one thing you need to pay attention to is for each objective, you shouldn't be solving it other than how it says. So if it says solve by graphing, you shouldn't be solving by substitution or elimination. If it says solve by substitution, you're not graphing or using elimination. If it says elimination, you're not using substitution graphing. Word problems is free for all. So for this number 9, you are solving by substitution. Look for one of the variables that's either almost by itself or has like a negative. Solve for that variable because you won't have fractions. So I'm going to subtract 5x to the other side. So we have negative y equals negative 19 minus 5x. Y still needs to get by itself, so we would divide everything by a negative 1. So that y equals positive 19 plus 5x. Now we have an equation that has a variable by itself. And we're going to take this part of the equation and put it into the other, where y is. So negative 5x plus 8, and then in parentheses, everything we just solved, 19 plus 5x, and then equals negative 23. And from there, you would start solving. Solve for x, and then go back and solve for y. Someone multiply 8 and 19. Tell me what that is. Combine your like terms. The negative 5 and the 40 would give you a positive 35x. And then subtract 152. So we have negative 175. And divide. Divide that to what you get. So once you find x, you're going to put that back into one of your equations and solve for y. And then figure out what that is. So 19 minus 25. Negative 6. And then make sure you write your final answer as an ordered pair, x and then y. Questions on that one? Other questions from the review? Taylor?
16.
16. Asking which one were you going to say? 12. So we'll do 12 first and then go back and do 16. So if you see something like 12 where you have two equations in the substitution that are both solved for a variable, you can set them equal to each other if these are the same variable. So since these are both y, I can set them equal to each other. And then solve. Get all your variables on one side, all your constants on the other.
Why are you doing like that?
Because here I'm substituting this into this y or this into this y. And when you do that, they are equal to each other. So then I can add 3x and subtract 15. And divide to solve for x. And once you have your x, you can put it back into either equation for y. Doesn't matter which one. So let's say I do the first one. I would be putting that in for x and then solving. And then once you have x and y, put those together in an order. Questions on 12? So you'll see more like the last one we did than 12, but you may see at least one of the questions at 12. 16, we are now solving by elimination. So the rules have changed. We have to think that the rules have changed. We are now looking for a common coefficient. Right now we don't have one, so we have to make one. Doesn't matter if that's your x's or your y's, you choose. Let's say I wanted to get rid of my x's, so I multiply everything by 3. And that new equation becomes negative 9x plus 24y equals negative 18. Then I would be thinking about how could I eliminate my x's. And if you're not sure, especially if they have different signs, put it in your calculator, double check. So if I did 9 plus a negative 9, those would cancel. But 9 minus a negative 9 would not. So I would have to add the two equations together so that these cancel. Negative 24 plus 24, those would also cancel, leaving just 0. And 15 plus a negative 18 would be negative 3. And what type of solution would that be? No solution. So if your variables cancel with substitution or elimination and you're left with two different numbers, no solution. If your variables cancel with either of those and you're left with the same number, infinitely many. 17. Right. Same process. We're solving by elimination. Again, it does not matter if we get rid of the x's or the y's first. Let's say I get rid of the y's since we got rid of x's before. These would need to be the same. Something that they have in common if I multiply them by each other. So this by 10 and this by 7. So both equations are going to change. then if I'm getting rid of my y's, again, if you're not sure how would I eliminate these, you could calculate it. Taylor, what were you going to say?
Why are you dividing 10 to the negative 7?
Not dividing,
Instead of
multiplying.
Multiplying, sorry.
We're trying to get the y's to be the same.
Okay.
So one number I thought that they could both go into is 70. If you think of a smaller number, you can go with that. So again, if you're not sure, so I could do negative 70 plus a negative 70. That wouldn't cancel them. So I would have to subtract. So I'm going to subtract the entire equation from each other. But when I do that, these cancel again. So this would be infinitely many solutions. Other questions we want to see go over, Victor? 20. Eugene, did you have your hand up too?
Yeah.
Which one?
I did it for
Okay, which one?
2.
2. And we'll go back and do 2. Great. So find important things, highlight, circle, underline as you read. Anything that has numbers are important. So 2 chicken sandwiches, 3 bowls of vegetable soup, $16.50. 1 chicken sandwich, 3 bowls of vegetable soup, $9.50. And here we're looking for just the cost of a bowl of soup. Remember that question is going to help you define your variables. This tells you what you don't know. The variable represents what you don't know. So I'm going to call that B for the cost of a bowl of soup. There's a lot of A's and stuff that I'm missing in that, but we also need the other variable, even though it's not asking about the other one. So I'm going to say that C, the cost of a chicken sandwich. So define both of your variables, set up both of your equations. If you're given 6 numbers, you're going to be using all 6 numbers in the format ax plus by equals c. So I can say 2c plus 3b equals 1650. And then 1c plus 3b equals 950. After you set up your equations, you have choices. If you want to solve by graphing, go for it. Elimination, go for it. Substitution, go for it. Look and see which one best fits it. One might apply better than the others. Like this one, we have common coefficients, so elimination would be a better way to solve it than the other two. Because I could subtract. So this would just be C, these would cancel, this would be 7. Unfortunately, that's not what the question was asking. We still have to go back and find B. So put C back into one of these equations, doesn't matter which one, and solve for B. So we could subtract. And divide. Divide that, tell me what you get for B. $83. if you want to put it like this or put it like this, either or. So if you get something that's a repeating decimal, don't put 0.33333, cut it off. Think about what you're looking for. You're looking for cost. Cost is usually only 2 decimals, so put it as such. Make sure you're labeling whatever it is. If it's looking for cost, you need dollars or cents. If it's looking for amount, put whatever the label is. Do we have questions on this one? Okay. We're going to jump to 2 and then we'll come back to 25. We will set up 26 just for sake of time. So number 2, if these are in y equals, you can use your calculator to double check that you graph these correctly and find the intersection. If they're not in slope-intercept form, so like number 4, you would have to get them in slope-intercept form before you could put it in your calculator. But if it's in slope-intercept form, you're going to start at your y-intercept. So for the first one, start at -1. Use your slope. It's a positive 1/2. So go up 1 to the right 2 as many times as possible. Down 1 to the left 2 as many times as possible. Draw a line through all of your points. Draw arrows. If you need a ruler, there are some in the colorful trays. And then the same thing goes for the other one, except now you're starting at positive 2. Slope is still 1/2, so up 1 to the right 2, down 1 to the left 2. Do these lines intersect? No. So what type of solution do you have?
No solution.
No solution. If they intersect, that would be 1, and you would write that ordered pair. If they fall on top of each other, that's infinitely many. Before you graph it. Okay. Other questions on the graph?
4.
We'll come back to 4. We'll do 25 and then come back and do 4. And, do 25, set up 26, and then come back and do 4. 25 is a word problem, but not at the same time. It's really just math in words. Because here we have 5 times Jasmine's number minus 3 times Josh's number is equal to -16. And then we know that 4 times Jasmine's number plus 5 times Josh's number is equal to -35. And we need to know the value of both. So your variables would be something about their numbers. So let's say I'm going A and H. But you can call them X and Y, it doesn't matter. As long as I can tell which one is which and you're specific about it. So with this one, the first equation would be 5 times Jasmine's number minus 3 times his number is equal to -16. And then 4 times her number plus 5 times his number is equal to -35. So that one, it's not really talking about something realistic. It's really just math and words. So this one you could solve different ways. Substitution, I probably wouldn't advise. You could do graphing, but you'll have fractions. Elimination would probably be your best bet. But you would need to change both of the equations to something. So we could get rid of the h's by multiplying by 5 and 3. So 25a minus 15h equals something. Multiply 16 and 5 for me. And then 12a and 15h equals whatever 35 or 3 is.
Negative 105.
From here, you could add or subtract to eliminate your h's. I'm not going to continue that one, but that would be how you would start that one. 26 looks confusing because of all these x's and things going on. The part up here really has nothing to do with anything you need to set up. The questions at the end will help you define your variables. How much does it cost to ride the Ferris wheel? How much does it cost to slide down the water slide? So you can call that F and W, W and S, X and Y, it does not matter. To set up this equation, you would look at the number of times their card or ticket was punched. So 3 times for the water slide, 3 times for the Ferris wheel, this was their total. 2 times for the water slide, 3 times for the Ferris wheel, and this was their total. So you would set up the equations using those numbers. So 3W plus 3F equals 1770. And 2W plus 3F equals 1555. So it looks weird, but the setup is really the same. From there, you could choose which method you want to solve. Elimination would probably work best because you already have a common coefficient. And I'm going to stop that there. Whoa. Going back to number 4 on the front. To solve both of these equations, get y by itself. Subtract the 8x. I'm going to do that simultaneously. After you subtract the 8x, divide everything by 3. We have y equals negative 8 over 3x plus 4, and y equals negative 8 over 3x minus 3. Looking at the slopes, they're the same. The constants or the y-intercepts are different, so this is going to be another no solution case. So we have to go down and to the right since we can't go up. Lines may not be straight.
itself and you subtract AX, wouldn't that like cancel out the 8C?
Here, yes, not over here. Because you moved it to the other side. So this would still be no solution. They're just really, really close to each other. Any other questions? Main thing is make sure you know the difference between substitution and elimination. Don't do elimination on substitution and vice versa. Word problems, make sure you define your variable and label. Set up your equations and solve. Everyone go ahead and put your phone in a calculator pocket. Grab a calculator.